Welcome back. So last time we talked about polygons. Today we're going to talk about a special type of polygon, a parallelogram. Well, what's a parallelogram? It's probably going to have something to do with parallel lines. You're right. A parallelogram is a quadrilateral, meaning it's got four sides. Quadrilateral with both pairs of opposite sides parallel. Both pairs of opposite sides parallel. So side AD is parallel to side BC, indicated by those arrows. And side AB is parallel to side DC by these arrows. Notice these guys have two arrows, these have one arrow, so these are parallel to each other. And these are parallel to each other. All right, if we know that a quadrilateral is a parallelogram, we know its opposite sides are parallel, we also know some other things about this particular shape. If a quadrilateral is a parallelogram, meaning its opposite sides are parallel, then we also know its opposite sides are congruent. So we know PQ and SR are congruent, and PS and QR are congruent. If a quadrilateral is a parallelogram, meaning its opposite sides are parallel, then we know the opposite angles are congruent. So angle S is congruent to angle Q, and angle P is congruent to angle R. If a quadrilateral is a parallelogram, meaning its opposite sides are parallel, then we know consecutive. Following each other, the consecutive angles are supplementary. So angle S plus angle R, the measure of angle S plus the measure of angle R. Supplementary means what? Adds to 180 degrees. So let's give them a number here. For funsies, let's say that's 60 degrees. So if S and R are consecutive angles, which they are, and they're supplementary because it's a parallelogram, what's R going to be? Well, 60 plus what is 180? 120. Well, R and Q are consecutive, so they're also supplementary. So Q is going to be 60 degrees. And Q and P are also consecutive, so they're also supplementary. So Q plus P is 180, so Q is 60, P is going to have to be 120 degrees. Pretty cool. I still got that cough from last time, you know. And finally, we know that if a quadrilateral is a parallelogram, meaning its opposite sides are parallel, then the diagonals bisect each other. They bisect each other. Okay, so what that means, this diagonal splits this diagonal perfectly in half. And this diagonal splits this diagonal perfectly in half. So M is the midpoint of both SQ and PR. So PM is congruent to MR, and SM is congruent to MQ. All right, let's use these new found factoids on an example. So this figure here, oh no, it got chopped off. GHJK is a parallelogram. Let's find some of these unknown lengths. JH. Well, what do we know about JH? We know it's congruent to KG because those are opposite sides. So that guy is the same as GK, so it's 8 units long. How about LH? Oh, it's the same as KL because the diagonals bisect each other. So L is the midpoint of KH. So that's also 6 units long. Put those labels. How about KH? Well, KH now is made up of these two segments 6 plus 6, using our segment addition postulate. 6 plus 6 is 12. So KH is 12. Very good. All right, let's look at example number 2. In parallelogram ABCD, you see that right there? That's all symbol for parallelogram. In parallelogram ABCD, oh, we don't even have a picture for it. Oh my. Oh my. I guess we'll draw one, shall we? Parallelogram. Opposite sides parallel to each other. A, B, C, D. All right, obviously not drawn to scale. No big deal. The measure of angle C is 105 degrees. Find the angle measure indicated. The measure of angle A, well, what's that going to be? A is the same as who? A is the same as C because those are opposite angles. So A is also 105 degrees. How about angle D? Well, C and D are consecutive angles, so they are supplementary. So C plus D equals 180. So 105 plus the measure of angle D equals 180. What's that going to mean for the measure of angle D? Well, let's subtract 105 on both sides. So the measure of angle D equals 75 degrees. Great. Example number 3. WXYZ is a parallelogram. Find the value of x. Well, what do we know about these two expressions that have x in them? They're related to opposite angles. And those opposite angles are congruent. What's congruent mean? Got the same measure. So this equals this. 4x minus 9 equals 3x plus 18. We'll do a little subtraction action. X minus 9 equals 18 plus 9. So x equals 27. Yay! All right. You guys are doing great. We're going to move on to section 6.3, proving that quadrilaterals are parallelograms. We're going to skip, skippity skip, skippity skip, all the way down to these theorems to prove that a quadrilateral is a parallelogram. Well, previously we talked about if something was a parallelogram, then we knew some things. Now we're going to prove that something is a parallelogram if we know some things. So these are called the converse theorems. Before we knew it was a parallelogram, so then we knew some things. Now we're going to know some things and we will know it's a parallelogram. Okay? Cool. So if a quadrilateral, if a four-sided shape has, what do the opposite sides need to be? They need to be congruent. If those opposite sides are congruent, then it's a parallelogram. So if SR and PQ are congruent and PS and QR are congruent, it's a parallelogram. So then we would know that the lines were parallel too because it's a parallelogram. Wow. All right. If a quadrilateral has, what do we know about the opposite sides? They're going to need to be congruent too. So if we know that S and Q are congruent, and we know that P and R are congruent, then we have a parallelogram. So then we know the sides were parallel too. Great. If a quadrilateral has, what do we have for the consecutive angles? They needed to be supplementary. So if we know that the consecutive angles are supplementary, then we know we have a parallelogram. So remember we said if that was 60, this was 120, because that added up to 180. If that was 120, this needed to be 60, because that adds up to 180. If this is 60, that's got to be 120, because that adds up to 180. Very cool. And finally, if a quadrilateral, if a four-sided thing has diagonals that, what is that? What was that again? Oh, the diagonals, they needed to bisect each other, right? So that intersection there, that M, was the midpoint of both of those diagonals. So PM and M are congruent, and SM and MQ are congruent. If we know that thing is true, then what do we know? We got a parallelogram. That's correct. And if it's a parallelogram, what do we know? And them sides are parallel, yo. That's good stuff. All right. You're doing wonderful. I'm so proud of you. Oh. Y'all know I'll be liking this proof stuff. This is a good time. This is a real good time. All right, let's look at this example number 1. Given that triangle PQT, I'm going to use my pen that's got different colors here. Triangle PQT, that guy, maybe that was helpful, maybe it was not, is congruent to RST. We're going to try to show that this is a parallelogram. Wow. Well, first things first, let's put down what we were given. You know, got to start somewhere. Triangle PQT is congruent to triangle RST. That is given. They're helping us out here a little bit. They're saying PT is congruent to RT, PT is congruent to RT, and ST is congruent to QT. Well, why is that the case? Well, these triangles are congruent. So PT and RT, PT and RT, those are corresponding sides of congruent triangles. And what do we know about the corresponding sides of congruent triangles? They're congruent. And the same thing is true for ST and QT. ST and QT, those are corresponding sides of a congruent triangle. So they're congruent. So that's our old corresponding parts of congruent triangles are congruent. Doing great, guys. Doing great. Giving us some more hints. Definition of congruent segments. So what does it mean to be congruent? It means their measures are equal to each other. So we know that PT is equal to RT, right? If segments are congruent, then their measures are equal. Similarly, ST, oops, nope, see, I don't want that segment bar on top. Not if I'm saying their measures are equal, I'm just talking about the length of the segment. No segment bar on top. Very important distinction. These are congruent, or sorry, equal to each other by definition of congruent segments. So this means that PR and SQ bisect each other because, I mean, this is essentially saying that T is the midpoint, right? That's what bisect does, makes these two parts of that segment equal to each other. They have the same measure. So we've got these diagonals bisecting each other. So now we know that PQRS is a parallelogram because the diagonals of the quadrilateral, that's an L there if you didn't know. The diagonals of the quadrilateral, what do? They bisect each other. Yeah! Boom, 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 boom. Boom, 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 boom. Great transition! Okay, I'm going to put this up here so you can walk through this with me. We are proving this theorem that if one pair of opposite sides of a quadrilateral congruent and parallel, congruent and parallel, so QR and PS are congruent to each other and they're also parallel to each other, then that's actually all that we need to know as well. That's another way to prove that this guy's a parallelogram. So you're going to pause your video, and you're going to walk yourself through these steps, and you're going to put a little star there. I'm going to give you the points for it. Right? I'm going to check this out next time. You're going to put a little star there. I'm going to give you the points for it. Cool? And finally, all by yourself, you're going to fill this out too. You're going to look at your notes and figure out the ways to prove that quadrilaterals are parallelogram. Until next time, scholars.